Okay, so today we are going to finish 11.2. This is the last video you guys have. Since most of you are seniors, we are going to end after the exam tomorrow. So, you guys made it. Sad I don't get to celebrate with you. I wish I could, but hey, you made it. So, in part one, we look at how to calculate the number of ways a certain group of objects can be arranged in order matters, and we use the factorial notation. So that was this here. So n with an exclamation point. So however many things you have, you're going to use the factorial for that. In this section, we will look at how to calculate the number of ways a certain group of objects can be arranged when order matters. So it's kind of the same thing. We can use the factorial function when we arrange all objects in a particular order. How many different ways can you arrange 7 sports cars in your garage? Well, that's easy. You have 7 factorial. That would tell you the answer. Again, I have Desmos pulled up here. So you guys remember, this is your Desmos. You're going to go down here to the bottom left, and you're going to pull up your keyboard. We can type in 7, hit ABC, hit the exclamation point. That's 5,040. So that would mean then there's 5,040 ways. So how this changes is we're going to pick some of these. So it says when we want to pick some of the objects from the total amount, we want to use a permutation. So say you only have a 4-stall garage. How many ways can you arrange your 7 sports cars if it was a 4-stall garage? So not all of them would fit. So that's kind of what we're going to talk about here. So that's a permutation. So a permutation is when you take n things, you take them r at a time. So n is equal number of things, and I'll say r is equal to number of spots. So if you take my example, so if you have a 4-stall garage and you have 6 cars, you would say, okay, how many ways can I do 7 permutation with 4 spots? So that's what that would look. That's what that would look like. You have 7 cars and you're putting them into 4 spots. So it's n is the number of things, r is the amount of spots you have. So hopefully that makes a little bit of sense. So it says we are the coaches of a little league baseball team. There are 13 players on our roster, and we can play. That can play any position and bat in any order. Only 9 players start the game. How many ways can these positions be filled? So if you use the fundamental counting principle, you would have to have more than just that, because you would do 9 factorial with a factorial method. The fundamental counting principle, this is going to go on literally forever. It's not even worth putting it here. So this is just an example. So say you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You could then cycle through and say, okay, you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 11. There's tons. Like you can even switch the 2, the 3, the 4, the 5. There's so many ways to do this that you couldn't fit it on one sheet of paper. So instead of doing that, I'm going to say my n is 13. I have 13 total players. And my r is 9 because I'm putting this into 9 different spots. So this would be 13 p 9. So go to that Desmos calculator. So go to Desmos. This one's a little bit different. So if you look, let me find it. Okay, you want to go back to the 1, 2, 3. So your screen looks like mine. If you go to functions and go to stats, you'll see that the middle column, first from the bottom, however you like to say it, it's NPR. That's what we're going to use. So hit that NPR button. You're going to type in the number, which is 13, comma, how many spots you're filling in, which is 9. You know how long it can take you to figure out that there are 259 million? That's a million ways. That's a lot of ways. So this is going to be 259 million 559,000. So 259 million 259 million, and then 459,200 days. I don't think you do that by hand. Just saying. This here, that would be if we were using our calculators, which we obviously are not because we're not at school. So, Senior Student Council has 9 acting members. There's 9 members. How many different ways can you elect a president, a vice president, a secretary, and a treasurer? So we have N is going to be 9 members, and we are arranging them how many spots? Well, there's a president, a vice president, a secretary, and a treasurer. That'd be 4. So this is going to be an NPR. We're going to have 9P4. So if you go back to your Desmos calculator, you can just, if you want, you can just back that out, and you can type in 9, 4. So there'll be 3,024 ways. So there are 3,024 ways to elect a president, a vice president, a secretary, and a treasurer. So that's a lot of ways. Okay, how many different programming schedules can be arranged when choosing 5 sitcoms from a collection of 10 sitcoms? So they kind of changed the wording on this one. So the 5 is actually the R. There's 5 spots, and the number you're choosing from is 10. So this is going to be 10P5. So if you go back to your Desmos calculator, again, you don't have to erase it all. Just erase the numbers. You're going to do 10, 5, and you're 30,240. 30,240 ways. Okay, so it says we need to make a slight adjustment if we are trying to rearrange the order of certain objects if some of the objects are repeated. So it says arranging letters in the words for a word scramble. So that's what this would be like. There is a distinct formula for finding the number of distinct permutations when a duplicate item exists. So it says the number of permutations of n items where P items are identical, Q items are identical, and R items are identical is given by this. So basically what this is saying is you're going to take the number of items that there are and then divide it by the number of items that repeat. So how can we arrange the letters in the repeats? If you look, there are 5 factorial because there's 5 spots. There's 5 number of items. However, we have 2 numbers that repeat, or letters, sorry, that repeat. We have 2 Z's. So it'd be 5 factorial divided by 2 factorial. So in your calculator, you can do 5 factorial divided by 2 factorial. This is going to be 60. There's going to be 60 days to do that. So Let's this. So in Mississippi, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are 11 total items. Of those total items, I repeats 4 times. S repeats 4 times. P repeats 2 times. So underneath you're going to have 4 factorial, 4 factorial, 2 factorial. So in your calculator, you're going to do 11 factorial divided by 4 factorial times 4 factorial times 2 factorial. And as you see, these numbers keep getting smaller. That's going to be 34,650. Whoops. 34,650. So it cuts down on the number you can do things when things repeat. How ways can you arrange the letters in Bacon? Well, there's 1, 2, 3, 4, 5 letters. None of them repeat. So it'll be factorial. 5 factorial is going to be 5 factorial, 120. So this would be 120 ways. How many ways can we arrange the letters in the word banana? So there's 1, 2, 3, 4, 5, 6, 7, 6. 1, 2, 3, 4, 5, 6 letters. You have an A 3 times and an N 2 times. So this is going to be 3 factorial, 2 factorial. So in your calculator, you would do 6 factorial divided by 2 factorial times 3 factorial, and we get 60. So there'd be 60 ways that you could arrange these letters. You do have homework after this, so there's 34 to 54 even, so please make sure you do that. This is your last notes and homework. Exam tomorrow, and you guys are done. Make sure if you're a senior, you have any work that you have to make, please get it done tomorrow. My grades are due on the 28th, which would be today. So please make sure you get that done so I don't have to give you zeros for those. If you're not a senior, you have until the last day of school to catch up if you're behind. I hope you guys had a great year with me. I'm sorry that we did not see each other these last couple days. I'll miss all of you seniors, and bye.